Introduction to Process Safety. Process safety is a discipline focused on the prevention of incidents that could result in catastrophic consequences, such as explosions, toxic releases, or fires. It involves managing the integrity of operating systems by applying inherently safer design principles and disciplined operating practices. This approach is crucial in industries handling hazardous materials where the potential for severe incidents is high. The importance of process safety extends beyond the immediate safety of workers to include environmental protection and business continuity. Incidents in process industries can lead to significant loss of life, environmental degradation, and financial losses. By integrating process safety into operations, organizations can mitigate these risks and ensure sustainable operations. Collaboration between process safety experts and generalist OHS professionals is essential for effective safety management. While process safety focuses on technical and engineering solutions, OHS professionals bring a broader perspective on workplace safety and health. Together, they can develop comprehensive strategies that address both process and personal safety concerns. Understanding the principles of process safety is vital for OHS professionals working in high-risk environments. This knowledge enables them to engage effectively with process safety specialists and contribute to the development of robust safety systems. By doing so, they play a critical role in preventing incidents and ensuring the safety of both people and the environment. Historical perspective of process safety. Process safety is a discipline that focuses on preventing incidents that could lead to catastrophic outcomes, such as explosions, toxic releases, or fires, particularly in industries handling hazardous materials. It involves managing the integrity of operating systems by applying inherently safer design principles and disciplined operating practices. By understanding and controlling the risks associated with hazardous materials and processes, organizations aim to protect people, the environment, and assets from severe consequences. The importance of process safety cannot be overstated, as incidents can result in significant loss of life, environmental damage, and financial losses. Historically, process safety was often managed separately from occupational health and safety, OHS, leading to gaps in understanding and practice. However, integrating process safety with OHS practices can lead to more comprehensive risk management strategies, ensuring a safer working environment. Process safety management requires a collaborative approach, involving both process safety professionals and generalist OHS professionals. While process safety professionals typically focus on engineering and technical aspects, OHS professionals bring valuable insights into human factors and organizational culture. By working together, these professionals can develop and implement effective safety management systems that address both technical and human elements of safety. This course aims to provide OHS professionals with the knowledge and tools needed to engage effectively in process safety management. By understanding key concepts such as hazard identification, risk assessment, and control measures, OHS professionals can contribute to safer process operations. Ultimately, the goal is to create a culture of safety that permeates all levels of an organization, reducing the likelihood of incidents and improving overall safety performance. Extent of process safety problems. Process safety is a critical discipline focused on preventing incidents that, while rare, can have catastrophic consequences. It encompasses the integrity of operating systems and processes that handle hazardous substances, aiming to prevent loss of control that could lead to fire, explosion, or toxic releases. This approach is essential not only for protecting human life, but also for safeguarding the environment and ensuring business continuity. The field of process safety extends beyond the expertise of chemical safety professionals to include generalist occupational health and safety, OHS professionals. By integrating OHS perspectives, organizations can adopt a more holistic approach to safety management. This collaboration helps in addressing both the technical and human factors involved in process safety, thus enhancing overall safety outcomes. A comprehensive understanding of process safety involves recognizing the distinct roles and contributions of both process safety and OHS professionals. While process safety focuses on engineering and system integrity, OHS emphasizes the safety of individuals interacting with these systems. Bridging these disciplines fosters a culture of safety that is proactive and preventive, rather than reactive. The importance of process safety is underscored by historical incidents that have resulted in significant loss of life, environmental damage, and financial loss. Learning from past events is crucial in developing effective safety management systems. By studying these incidents, professionals can identify common failure points and implement measures to prevent similar occurrences in the future. Legislation and standards in process safety. Process safety is governed by a combination of prescriptive and performance-based legislative frameworks across different regions. In the United States, the approach tends to be more prescriptive, with specific standards like OSHA's Process Safety Management of Highly Hazardous Chemicals providing clear guidelines. In contrast, countries like Australia and those in Europe often employ a performance-based approach, requiring companies to demonstrate their safety management processes through safety cases. The safety case regime, particularly in Australia, emerged in response to major industrial disasters and is influenced by international standards such as the Seveso directives from Europe. This approach mandates a thorough analysis and documentation of all potential hazards, the implementation of control measures, and the establishment of a robust safety management system. The goal is to ensure that safety risks are reduced as far as reasonably practicable, aligning with the principle of continuous improvement. Compliance with these legislative frameworks is crucial for organizations operating in high-risk industries. It not only ensures the safety of operations, but also protects the organization from legal liabilities and enhances its reputation. Understanding and adhering to these standards is essential for both process safety and OHS professionals, as it provides a structured approach to managing safety risks effectively. In addition to national regulations, international standards, such as ISO 45001, provide a framework for occupational health and safety management systems. These standards emphasize the integration of process safety and OHS practices to optimize safety outcomes. By aligning with global best practices, organizations can enhance their safety performance and ensure compliance with both local and international regulations. Roles in process safety management. Process safety management involves a collaborative effort between various professionals to ensure the safe operation of industrial processes. The primary roles include process safety engineers, who focus on the technical aspects of safety, such as system design and hazard analysis. Generalist OHS professionals play a crucial role by integrating safety practices into the broader organizational context, ensuring that safety measures align with overall workplace health and safety strategies. Process safety engineers are typically responsible for identifying potential hazards and implementing technical controls to mitigate risks. They use advanced risk assessment tools and methodologies to analyze process systems and design safety measures. Their expertise in engineering principles is vital for developing inherently safer systems that minimize the likelihood of catastrophic incidents. Generalist OHS professionals, on the other hand, focus on the human and organizational aspects of safety management. They ensure that safety policies and procedures are effectively communicated and implemented across the organization. By fostering a culture of safety, they help to ensure that all employees are aware of and adhere to safety protocols, reducing the risk of accidents and incidents. Collaboration between process safety engineers and OHS professionals is essential for effective safety management. By working together, these professionals can ensure that both technical and human factors are considered in safety planning and execution. This integrated approach not only enhances safety outcomes, but also promotes a culture of continuous improvement in safety practices. In addition to engineers and OHS professionals, management plays a critical role in process safety. Leaders are responsible for setting the tone and priorities for safety within the organization, ensuring that adequate resources are allocated to safety initiatives. By demonstrating a commitment to safety, management can influence the entire organization to prioritize safety in all operations. Hazard identification and risk assessment. Hazard identification and risk assessment are foundational components of managing process safety. These processes involve systematically identifying potential hazards associated with industrial processes and evaluating the risks they pose to people, the environment, and assets. The goal is to understand the nature and magnitude of risks to inform the development of effective control measures. To effectively identify hazards, professionals use a variety of tools and techniques. These include qualitative methods like hazard and operability studies, HAZOP, and quantitative approaches such as layer of protection analysis, LOPE. Each method offers different insights, allowing safety professionals to comprehensively assess potential risks and determine the likelihood and consequences of hazardous events. Risk assessment involves estimating the frequency and severity of potential incidents. This process uses data from historical incidents, engineering analyses, and expert judgments to evaluate the probability of hazardous events occurring. By understanding these risks, organizations can prioritize safety measures and allocate resources effectively to mitigate potential impacts. Incorporating engineering drawings and understanding failure modes are critical aspects of risk assessment. Engineering drawings like process flow diagrams, PFDs, and piping and instrumentation diagrams, PNIDs, provide detailed insights into the process setup and potential points of failure. Recognizing failure modes helps in predicting how and why equipment might fail, enabling proactive measures to prevent such failures. The role of generalist OHS professionals in hazard identification and risk assessment is to bring a broad perspective to these technical evaluations. They contribute by ensuring that assessments consider human factors and organizational influences that might affect safety. Their involvement ensures a holistic approach, integrating technical assessments with an understanding of workplace dynamics and human behavior. Control measures in process safety. Control measures in process safety are designed to prevent incidents and mitigate their consequences. These measures are categorized into elimination, prevention, evaluation and assurance, and mitigation. Each category plays a critical role in maintaining the integrity of operations and ensuring the safety of personnel and the environment. Elimination through design focuses on removing hazards at the source by redesigning processes and systems. This approach emphasizes inherently safer design principles, which aim to minimize the presence of hazardous substances and conditions. By reducing the potential for hazardous events, elimination through design provides a foundational layer of protection. Prevention involves implementing controls that prevent hazardous events from occurring. This includes engineering controls, such as alarms and shutdown systems, and administrative controls like permit-to-work systems. Prevention measures are proactive, aiming to stop incidents before they happen by maintaining safe operating conditions. Evaluation and assurance ensure that safety systems are functioning as intended. This involves regular testing, monitoring, and auditing of safety-critical elements to verify their reliability and effectiveness. Assurance activities help identify potential weaknesses in safety systems, allowing for timely corrective actions. Mitigation strategies are employed to minimize the impact of incidents when they occur. These include emergency response plans, fire suppression systems, and containment measures. Mitigation measures are essential for protecting people, property, and the environment from the effects of process safety incidents. Implications for OHS practice process safety is an integral part of industrial operations, focusing on preventing incidents that could lead to catastrophic consequences. It involves managing the integrity of operating systems by applying inherently safer design principles, engineering, and disciplined operating practices. The goal is to prevent and mitigate incidents that have the potential for a loss of control of hazardous materials or energy, which could result in severe outcomes such as fires, explosions, or toxic releases. The importance of process safety extends beyond the confines of process safety professionals, emphasizing the need for collaboration with generalist occupational health and safety (OHS) professionals. By integrating process safety knowledge into their practices, OHS professionals can contribute significantly to managing hazards in environments where high-risk processes occur. This collaborative approach not only enhances safety, but also ensures that both personal and process safety are addressed comprehensively. Understanding the principles of process safety is crucial for OHS professionals, enabling them to engage effectively with process safety specialists. This knowledge empowers them to operate successfully in high-hazard environments, ensuring that safety measures are robust and comprehensive. By bridging the gap between process safety and OHS, professionals can work together to create safer workplaces, reduce risks, and prevent incidents that could have devastating consequences.